Hello everybody. Today we are going to discuss about sorting methods, and in our experiment we are going to focus on two sorting methods: selection sort and insertion sort. That's what our experiment is for today. So first of all, before beginning with the program, let's understand how insertion sort and selection sort works. So beginning with insertion sort, the algorithm for insertion sort says if you have an array like this, for example as shown here, you can compare the first two elements. For example, here you compare 14 and 33. So which one is greater, which one is smaller, is moved to the left hand side, is swapped with the greater one. So here, as you can see, 14 and 33, 14 is lesser than 33, so it's placed in the right position, so you do not swap. But then after that, when you increment min, so you get 33 and 27. So in this case, 27 is lesser than 33, so it's swapped. So 27 is brought into the position of 33 and 33 is brought into the position of 27, as you can see here. In that case, now 33 and 10 is compared. For that, 10 is smaller than 33, so 10 is brought into the position of 33 and 33 is brought to 10's position. So that's the way you sort it. But now, as you can see, since 10 is lesser than 27 also, you compare those two and you bring 10, swap 27 and 10, and then 10 is indeed smaller than 14, so you swap 10 and 14 also. So that's how the algorithm works. So we will just see how, the insertion sort program. I made a program here in code blocks. So you begin by including the header file #include iostream and the standard library file using namespace std. I've defined the insertion sort function here. So in that we have passed three arguments. It has three parameters: int a, that's the array, n, that's the size of the array, and k, which is the loop variable. So here, as I told you about the algorithm, so you have a for loop here which starts with 1 and which will go up to n minus 1, and it will be incremented every time. So you create a temp variable and you store the very first element of the array in temp, and j will be k minus 1. So every time you will compare the two elements, while temp is less than aj and j is greater than equal to 0, a of j plus 1 is equal to aj. Here swapping is happening. I hope you understand that. Here swapping is happening, and you decrement j is equal to j minus 1, and whatever was there in a of j plus 1, you put that equal to temp for the next iteration. So I hope you understood. The algorithm is simple. So you begin by initializing main, and I have declared four variables here: n, which is the size of the array; I, a loop variable; t for temp; and a of 10 is the maximum size of the array. Enter the size of the array, n, which will be given. Enter the array elements. Using a for loop, we have asked the user to enter the array elements. Since the function name is insertion sort, and we passed three arguments here, a, n, and I, and we've used a for loop again to display the sorted elements. So let's just have a look at the output. Enter the size of the array. For example, if I enter 10, array elements 9, 8, 7, 6, 5, 4, 3, 3, 3, and 2. So if there are three threes, then it will display properly. So that's a perfect algorithm. I hope you understood that. Now let us move on to the second algorithm which we are going to discuss today, and that is the selection sort. In selection sort, what you do is you select the first element and then you search through the entire list of array and you find the smallest element and you swap it with the first element. For example, we considered 14 first, then we traced through all of the elements in the array, and so then we swap 10 and 14, and after placing 10 into the first position, then you increment the variable's value, and then you consider 33 now, and then you'll trace the list again and find out the minimum element and swap that with 33. For example, here 14 is the second minimum element, so you swap 14 and 33. So that's how you do it. You keep on repeating this unless you get a sorted list. So I've made a program here in code blocks for selection sort. Let us have a look. So you begin by including the header file #include iostream and the standard library file. Here we have defined the function. So but before that, let's come on to main. Inside main, we have four variables: n, which is the size of the array; k, the loop variable; and loc, we will see what it is used for; temp, a temporary variable; and a of 10, which is the array declaration. So enter the size of the array, which is stored in n, and the array elements using for loop. We are asking the user to enter the array elements. Now inside this for loop, as you can see here, it will go up to n minus 2, because the first element will be always sorted. So it will just move up to n minus 2. And here I have defined a function min, which will give the position of the minimum element, that is LOC, and that position will be stored in LOC. Since it's an integer variable, the position, the index of the element will be stored. And you have created a temporary variable in which you store the value of a of k, and a of k will be equal to a of LOC, and a of LOC equal to temp. Here everything, all swapping is happening here. And after that, you use a for loop to display the array elements, the sorted array elements. But before that, the main important thing that we need to understand is how we define the min function. So here the return type for min function is int, since it is returning the position, the index. And we have passed three parameters or three arguments: int a, that's the array; int n, that's the size of the array; and k, the loop variable. So int min and LOC we've declared two integer variables, and inside min we have stored the value of a of k, that's the very first element of the array, and LOC equal to k, the index of the array. So for int j is equal to k plus 1, it begins with the second element. The first element is considered and it begins with the second element, and j is less than or equal to n minus 1 j plus plus. You find the greatest, the minimum, most least number. So if min is greater than a of j, so you put min is equal to a of j and you store the index value in LOC. So min is the predefined function here in code blocks in the standard library file, and you just return the index. So let's just build and run and see if it works. Enter the size of the array. Suppose if I enter 10, the array elements 8, 7, 6, 98, 5, 4, 3 and 2, 2, 2. So as you can see here, it's a very proper sorted list. So I hope you understood. It's easy. Thank you.